Hello everyone, my name is Nick, and in the series of lessons we are going to introduce you to programming concepts using C. These lessons are meant for someone with very little or no prior experience in programming. We'll be starting with very basics and taking everyone along with us. So what is programming? Programming is an art that is mastered through immense practice, patience and experience. So let's understand what is the basic computer and what are programs. So if we say a computer is a general purpose machine that can perform complex scientific calculations at a very high speed, but it cannot perform the tasks on its own. A computer needs a set of instructions to do some tasks. These set of instructions are contained in a computer program. A computer uses input devices to take instructions from the user and gives out the results in the output devices. So how does these instructions are understood by the computer? A computer has hundreds and thousands of computer programs that manages all the resources. Some programs handles the hardware resources of the computer. We call them system programs, and there are programs that perform our day-to-day tasks. These programs are known as application programs. For example, a calculator. For a calculator, when we give some inputs like 8 minus 5, it will give us the output as 3. So a set of instructions are going inside the calculator and it's giving us the output. Similarly, there are other application programs like a web browser. We surf the internet and search whatever we need through a web browser. Another example of an application program is a text editor. We open Word and we write some text and save it for further reference. This is also an application program. And any of these programs, if it cannot perform our needs, we can write our own programs. And this is what we are going to learn in this series of lessons: writing and executing our own programs. As we understood now, to make our work done, we need to feed the computer with a set of instructions, and the computer would execute those instructions. But in what language can I give these instructions to the computer? Can we give these instructions in a natural language like English or Hindi? Not exactly. We need to communicate the computer through the language it understands. So the binary number system is the language of the computer. Computer only understands binary. Binary is a base 2 numeral system with a radix of 2. That means there are only 2 digits, 0 and 1. So a binary number is also called a bit. If you have only one bit, you can have two possible values, that is either 0 or 1. If you have 2 bits, we can have 4 possible values, that is, as we can see, 0 0, 0 1, 1 0 and 1 1. So let's suppose if we have n digits, we can have 2 to the power n number of different possible values. So the basic computer systems nowadays have 64 bits. So 64 bits means 2 to the power 64, which is equal to this much number. So this is the different values that we can have in a 64-bit number. So it has a high computational values that we can have in nowadays general purpose computers. So there are other number systems too, like a decimal number system, which contains 0 to 9, and the hexadecimal number system, which contains 0 to 9 and other alphabets from 1A to F. So why computer uses only binary number system? Why not decimal or the hexadecimal number system? The reason is binary is really very easy to simulate in an actual physical design of things. Computer is an electronic device and it is very easy to create the logic of 0 and 1 in an electronic circuit. For example, we can simulate this with off and on, where off means 0 and on means 1. So if a current is flowing through the circuit, it can be taken as 1, and if it is not flowing, it can be taken as 0. So where did this logic came from? The binary number system can be routed back to the ancient times. But it was in the year 1854, British mathematician George Boole published a landmark paper detailing an algebraic system of logic that became the Boolean algebra. His logical calculus became the instrumental in the design of digital electronic circuitry. So the logic gates that we see, AND, OR, NAND, everything is based on the Boolean algebra, and according to that the different circuits are designed nowadays. Computer used those digital electronic circuits to understand the instructions that we feed and perform the likewise operations. So the first programming language were written in binary, and which interacted with the machine and gave us the output. Since the starting of the programming language, it is classified into three categories. Sometimes it is also known as levels or generation of programming languages. So if we see, all the computer programming languages are broadly classified into the following: the machine level language or the first generation language, the assembly language or the second generation, and the high level language or the third generation of the language. So what is machine level language? It is the lowest level and consists of binary numbers. It directly interacts with the computer system and does require very less time to execute, as there is no conversion taking place in the system. Let us understand how programming was written in the machine language. For example, let us suppose that we have a 9-bit architecture system. So for the first 3 bits, it represents the opcode of the machine level language. The second 3 bits defines the operand 1, and the last 3 bits defines the operand 2. So since we have a 3 different parts, so 2 to the power 3 gives us 8. So we have 8 different combinations. So if you say 8 different combinations are 000, 001, 010, 011, 100, 101, and likewise. So let us suppose the last 2 digits here represents the operations addition and subtraction. So if you say, we can write it 100 represents addition and 101 represents subtraction, and 000 represents 1, and 1 likewise. This represents 2, 3 and 4. So if we want to write a program, we have to write, if you want to add 1 with 2, we will have to write the opcode first. So we are saying addition, so first 3 digits will be 100, and we will be and second one would be 000, and the second second operand would be 001. So the computer would understand that we are saying to add 1 to 2. Likewise, if you want to subtract 2 from 1, so we have to write what? 101, 001 and 000. This would be understood as from the computer, like 101 is subtraction, and we have to subtract 2 from 1, and it would give us the output. So if you see, these instructions were very hard to understand. It is also consuming a lot of time, and you have to memorize a lot of things. Moreover, this is also machine dependent, and we cannot write the same code for a different architecture system. For example, for a 64-bit architecture system, the same code would not work. So it would understand different thing for the same line of code. If we give 101, 001, 000 for the 64-bit architecture, it would be something else for it. It would do a calculation according to the different opcodes it has been defined for it. So the second generation of languages came into existence. The second generation of languages made the work a bit easier. It it basically contains variables which were called commands instead of the just binary numbers that we feed. Instead of writing binary numbers, we could now write add 2, 3. So this basic command would be understood by the computer as addition of 2 and 3. So there were several different types of code saved for different operations that we do. For example, for subtraction we would use sub, for multiplication we would use multiply, and likewise for different applications. So this were known as the mnemonic codes, and these made our work bit easier. But here is a catch, as we know, computer only understands binary language. So how was it able to understand the assembly language and these instructions? The answer is, for that programmers wrote a general program called assembler, which could translate the assembly language to the equivalent binary representation. So the assembly language would be fed into assembler, and the assembler would translate into equivalent binary numbers, and the computer would be able to understand that language. Assembly language had its own benefits. We can write any of the machine dependent tasks in an easier format and in a better way, and it required less time for execution. But it was also machine dependent. It was not portable to the different architectures also. The third generation of languages were called high level languages, as the languages are closer to the natural languages like Hindi or English. It was easier to understand and remember. It was also taking less time to understand those programs, and most importantly, they were portable, and the same program could be done on different machines. Like assembly language, high level language also required a software or set of programs to translate it into machine understandable format. This software is also called a compiler or an interpreter. So the high level languages were divided into two categories. Some were called compiled languages and the others were called interpreted languages. Compiled languages are C, C++, and an example of interpreted language is Python. So the compiled or the interpreted languages were classified because of the translator it used. It was wholly dependent on the translation process and not language dependent. A language could be interpreted or translated. According to the needs and the demands, it was either made interpreted or compiled. So the third generation languages used either of these two to convert it into the machine understandable code. Now what's the basic difference between a compiler and an interpreter? In a compiler, when the compilation process is going, the program is not executing. It translates whole of the code in a single instance. So if we say we write a code and we save it, it is taken completely and then translated into machine understandable code. There is no scope of changing the code in the between of the translation, and it actually increases the time for the debugging. For interpreter, the translation is done line by line. For like if we write a line of code, it is interpreted into the machine understandable code, and likewise every line is translated. So when the translation is ongoing, it will interpret it and it will generate errors, and it would reduce the time of the debugging, and we could update the code in the middle. So the compiler generates error messages only after the scanning is completed. Interpreter continues to translate until an error is found, and we could rectify the errors, and the translation can move further from there. The interpreter thus is considered better for debugging process. Also, the scanning time is high and the execution time is less in the compiler. As it saves an executable file, it also needs an extra memory. For the interpreter, scanning is faster for a single line. Overall execution time is very high, but the interpreter does not save any executable file, and it translates the codes every time we just run the code, and thus it doesn't require any extra memory to save any file. As we discussed, the programming language, it was on the need and the demand, was made either interpreted or compiled. So moving further, how the programming languages evolved. What we now see are the high level languages. So what was the timeline and how it was actually evolved? Programming languages, believe it or not, had existed for more than 200 years. Ada Lovelace is referred to as the first computer programmer. She closely worked with Charles Babbage, and in her notes she not only explained the analytical engine more clearly but also described an algorithm it could carry out. That is often considered to be the world's first computer program. It was a whole 100 years before the first electrical programmable computers would burst into existence. However, machine-specific assembly language in the 1940s was probably the first human-readable language. But the 1950s, computer engineers realized that assembly language was far too laborious and error-prone to build. Thus, in the 1950s, the first modern programming language was born. In the year 1957, Fortran was coined. So, Formula Translator is the oldest language which is still in use. It was created by John Backus and it is still used in aerospace, automotive industries, and the research institutions. It was developed to perform high-level scientific, mathematical, and statistical computations. The year 1959, Common Business-Oriented Language was developed. It is behind the majority of the business transaction systems running credit card processing, ATMs, telephones, and cell systems. The COBOL development team, led by Dr. Grace Murray Hopper, set out to create a uniform, user-friendly language for business transactions. In the year 1964, BASIC was developed. It was developed by the students of Dartmouth College. Beginners' all-purpose symbolic instruction code were designed to be a simplified language for those without a strong technical or mathematical background. It was modified by Bill Gates and Paul Allen, and it became Microsoft's first product. In the year 1969, the language C was coined. It was developed by Dennis Ritchie of the Bell Laboratories. It was basically designed to develop the Unix operating system. We will be further getting into deep knowledge of C, but let's see about other languages too. The year 1970, Pascal, which was named after Blaise Pascal, was created. Then the first object-oriented programming, C++, was created in 1983 in the same Bell Labs. C was modified into C++ and created what may be considered the most popular programming language ever. It has been listed in the top 10 programming languages since 1986, and it has achieved the Hall of Fame status in the year 2003. It is being used by MS Office, Adobe, Firefox. Most of the common applications uses C++. In 1987, Perl was made. Larry Wall, a Unix programmer, created Perl after attempting to extract data for a report and finding Unix couldn't perform the operations he needed. Practical Extraction Report Language, or Perl, was described by its inventor as a language for getting your job done. 1991 was the year when Python was made. Python is the most famous language nowadays, and it's been used by Google search engine, YouTube, and even NASA. Mostly it is used in AI and machine learning too, as it's easy to implement code using Python. In the year 1995, different programming languages were developed. One of them was PHP, Java, and even JavaScript was developed in the year 1995. Java was developed by Rasmus Ludford to replace a set of Perl scripts used to maintain his personal homepage. Today, PHP has grown into an integral part of web architecture, running on over 20 million websites. PHP is being used by Facebook. Now, the Java, a team of Sun Microsystems developers led by James Gosling, created Java to run set-top boxes for interactive television. Java now runs on over 1.1 billion PCs worldwide, and many of the websites cannot function without it. It was even used by the 2004 Mars rover. So we discussed about different programming languages. Now let's focus on C. So C is a general purpose high level language that was originally developed by Dennis Ritchie for the Unix operating system. It was first implemented on the Digital Equipment Corporation PDP-11 computer in the year 1972. The Unix operating system and virtually all Unix applications are written in the C language. C has now become a widely used professional language for various reasons. As it is easy to learn, it is a structured language, it produces efficient programs, and it can also handle low-level activities. By 1973, Unix OS almost was totally written in C. Most of the state-of-the-art software have been implemented using C. C was initially used for system development work, in particular the programs that make up the operating system. C was adopted as a system development language because it produces code that runs nearly as fast as code written in assembly language. All the C programs are written into text files with the extension .c. For example, helloworld.c. So this is the basic syntax of C language, and if we just write this set of lines in a text editor and save it in the extension .c, it will become a C program. A C program basically has the following form: preprocessor commands, functions, variables, statements and expressions, and comments. This following program is written in C programming language. So the preprocessor commands, these commands tells the compiler to do preprocessing before doing the actual compilation. Like #include stdio.h is a preprocessor command which tells the C compiler to include stdio.h file before going into the actual compilation. Functions are the main building block of any C program. Every C program will have one or more functions, and there is one mandatory function which is called the main function. This function is prefixed with keyword int, which means this function returns an integer value when it exits. This integer value is returned using return statement. The C programming language provides a set of built-in functions. In the above example, printf is a C built-in function which is used to print anything on the screen. C is a case-sensitive programming language. It means in C, if you write printf, and if you write capital P in printf, it will have different meanings. Likewise, it is a free form line structure. End of each statement in C must be marked with a semicolon. If you can see, every line that I have written has a semicolon in the end. Multiple statements can be on the same line. If you write printf hello world semicolon, and in the same line if you write return 0 semicolon, it will give you the same output as it does now, because semicolon marks the end of the line. White spaces are ignored in C. If you give any space or tab, the C compiler ignores them. So let's just try to write a simple C program. Before writing a C program, we need to have some dependencies installed on our system. As we had discussed before, C directly cannot be understood by the machine. It only understands binary, so we would need a C compiler installed on our system to compile that into machine understandable code. For that, how to install a C compiler? You can just Google download C dev C++ IDE in Google tab, and you will find various links to download C compiler. So I am using this URL to download the link C compiler. So now what you have to do, just download the executable and run it on your machine. So if you can see, I have downloaded the exe for dev C++. You can just right click on it and run as administrator. It will run the executable file. So select English and then click on I agree, next, and install on the destination folder. So it will be extracting different files and will be installing that. As you can see, the wizard has completed to install, so click on finish. As you can see, the dev C++ has been installed on this location of your system. Now just right click on your system, click on properties, then advanced system variable. It will open the system properties of your system. Now we have to add an environment variable for dev C++. So new /bin, click on OK. So now you are done with the prerequisites. You can now run the dev C++ on your system. Now open dev C++. Click on new project, console application, write project name and select the C project. OK. Save. So I have written a simple hello world program here, as you can see. So to run this, just click on execute and compile and run. It will be giving you the output. So if you see, here we go, the output of our first program, hello world. As you can see this, as we have written our first program. So let's just recap what we have learned in this lesson. First of all, we understood the basic concepts of programming. What is binary and why do computer use only binary number system? Next, we understood the different generations of programming language. The first generation or the machine level language, the second generation or the assembly level language, and the high level language. Further, we classified high level languages into two different language. In first was compiled language, the second was the interpreted language. Next we understood the difference between compilers and interpreters. And further going, we saw the evolution of the different programming languages. We discussed about Fortran and Java until Java, what are the different languages that had evolved. Then we understood the basics of C programming language. What are the different preprocessors, what is printf, everything we discussed. And then we wrote our first program in C. So further in these lessons we'll be covering C in depth and understand what are the different data types, functions and everything whatever there are in C. Thank you guys.